Hey guys, welcome to this video. Today I want to show you one of the extra credit problems which you can solve. If you do it correctly, I'll give you a 3% extra credit. So yeah, if you're one of my students, no matter which class you take in, you can go ahead and do that. If you're not one of my students, you can try to solve this one. Send me an email. I'll tell you if it's right or wrong. We'll discuss that. The most important thing is to have fun, potentially receive extra credit, and improve your logical thinking. So here's the problem. You're given a deck of cards, of n cards. You know that number n, let's say that's 8 or 52 or 90, doesn't matter. But you basically know the size of the array or the deck of the cards. And on each one of those cards, you have a natural number. Or like, let's say rational number. Not natural, but rational number. Well, in other words, any number, okay? Maybe negative, maybe positive, maybe 1 billion, maybe negative 1 million, maybe 2, maybe 5. Doesn't matter. Anyway, so given the deck of cards, and the idea is that you need to find, so let's say like that's the deck, we have 3, 1, 2, 3, so there may be duplicates, 45, 6, 7, and 15. And your objective is to find the lowest value in that deck of cards, the lowest value, okay? So in this case, what's the lowest value? That's going to be 1, okay? And if you took 192 to 26 classes, you probably know about linear search and binary search. Binary search is not going to work because we don't have a sorted array. But linear search would, right? So the idea is that as you traverse the array, as you look at those cards, like one by one, you memorize the lowest value, and that's the one you're going to be declaring as lowest value. Okay. So, for example, in this case, you'll take a look at 3. You memorize that as 3 being the lowest value. Then you'll take a look at 1. 1 is lower than 3, right? Then so you will memorize 1 is the lowest value. Then take a look at 2. 2 is greater than 1. 3 is greater than 1. 45 is greater than 1. 6 is greater than 1. 7 is greater than 1. 15 is greater than 1, right? And then you can declare 1 to be your lowest value. So this problem is a bit more difficult, I guess much more difficult. And that's why it's worth like 3% extra credit. Here's the problem. The idea is that you're given the deck of cards and you're looking at one number at a time, right? And if you need to decide right there, right then, okay, right here, right now. You're looking at 3 and you need to decide, is that going to be my lowest value? Okay, if you decide that no, if you decide to move on, you completely throw away 3 and you move on. Okay, then you look at 1, you take a look at 1, and you're thinking maybe there is 0, maybe there is like negative 45, maybe there is negative billion. So you also decide to move on, and you completely throw it away. Okay, and after that, when you threw them away, you will not be able to declare them to be the lowest numbers. Okay, because again, you're looking at the number and you decide right there, right then, if that's going to be your lowest number. So, for example, in this case, if you throw away 1, there is no way you'll be able to find the minimal value because the minimal value was 1. Okay, so in this case, you definitely lose. You lose this game. And of course, again, if 1 was the first number, and like for example, you decide to skip that, right, because you haven't seen the rest of the array. In this case, you're definitely going to lose, right, because you skipped the lowest number. And obviously, the probability of winning in this scenario, in this kind of version of finding the lowest value, is definitely less than 0. Less than 100. Okay, so you cannot win 100% of the cases. That's impossible. So what you need to do, your objective, is to find a strategy of solving this problem such that your probability of winning would be the highest. Okay. Yeah. So of course, again, like if you, for example, pick the very first card always, so if your strategy is always to pick the very first card, right? In this case, it's possible that the lowest number was on the first card, right? Which means the probability of that happening is 1 over n, right? 1 over n. There are n possible positions, and the lowest number can be like in any of them. So 1 over n is probability that the first card will be the lowest. And of course, in the strategy where you always pick the first card, you will win only in 1 over n case scenarios. So like if n is, I don't know, 8, then in this case it's 1 over 8, okay? So that's of course very naive. There are definitely solutions where you'll be win with the bigger probability. So your task is to find the strategy and the probability in which you win the biggest amount of cases. Okay, so the best strategy in order to win this game, and what is the probability of winning in that strategy. yeah, hope it makes sense. Let me know if you have any comments, any questions. Comment down below. I'll see you guys next time. Bye bye.